This old thing has sumos on it. Thank you guys.
I thought they were turtles, not gonna lie.
No, they're sumos.
That makes it much cooler.
That's a wacky shirt.
Thank you. Thanks, y'all. All right, let us learn alternating series. These are kind of fun, even though they look scary. Like if you look at at them written in Sigma notation, they can look confusing, but they're actually pretty. I mean, they're not super hard. They just they're called alternating because they alternate in sign. Like they do 1 minus a half plus a third minus a fourth. So they alternate positive, negative, positive, negative, positive, negative. And again, the way you write that in Sigma notation is to put a -1 in the front, like because -1 to an odd power would be -1, and -1 to an even power would be +1. So that's what's making it alternate. So you can usually tell very easily what's an alternating series by this -1 in front. This dude right here will make it an alternating series. Question.
All that does is just change the sign. It doesn't do anything else.
Yeah, well, yeah, I know. Yeah, if you take some time to think about it, you would be convinced that, yeah, all it does is make it plus, minus, plus, minus, plus, minus. It doesn't affect anything else. And then this tells you how to check if an alternating series converges or diverges. But let me get a quick check on your intuition. Do you think these have a better, like, do you think these are easier to converge or harder to converge? If I'm doing plus, minus, plus, minus, plus, minus. Yeah, of course. They're going to be easier to convert because instead of adding, getting bigger, 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 these get big, then small, then big, then small, then big. You're like, half the terms are taking away some amount. So these are easier to make converge. And if you check the what's called the alternating series test, you can see that there's almost no requirements as long as where does it say? Look at they converge as long as the limit is 0. The limit of the non-negative part is 0. Well, basically, they also have to be decreasing. So in general, as alternating series converges if it's alternating, if it decreases, and if its limit is 0. Those are the only 3 things that have to happen. So that's like many, many, many more series than non-alternating series. And then this part at the bottom talks about like if you don't get a limit of 0, then for sure those are going to diverge, but not necessarily by the alternating series test. That's just the nth term test. So they want you to watch out. But I'll show you in an example what they want you to watch out for. So watch this. Example 1. Check if that converges or diverges. Well, let's just check the relevant thing. Like the main thing, basically the thing that will most of the time determine if they converge or diverge is that limit requirement, that whether this limit is 0 or not. So let me take the limit as n goes to infinity. And again, that's the limit of the non-negative 1 part. So makes it a little bit easier to think about. It's just the a to the n part. That's what this says. So ignore the -1 and just take the limit of n over 2n minus 1. Okay, and hopefully you've had enough reminders of limits that you see that that limit is what right away. Yeah, 1/2. Be careful with this. This is a n to the 1n to the first over 2n to the first, so 1/2, a ratio of the coefficient. Cool. Okay, so what that means is that the series without the alternating part would end up adding terms that, like when they get big enough, you'd end up adding terms that are close to 1/2 plus 1/2 plus 1/2 plus 1/2 plus 1/2. When it's alternating, it's going to do plus 1/2 minus 1/2 plus 1/2 minus 1/2 plus 1/2 minus 1/2. But in particular, they're not getting close to 0. So this has no chance of converging. So you would say this diverge. Well, we could write it formally. This n equals goodness. Okay, give me a sec. Here's what I did yesterday. Show all borders. Get rid of this in general. Get rid of that. Get rid of this. Make this big. Make this big.
Yeah.
All right, now for real. This sum from n equals 1 to infinity. Diverges. But what I was saying is they don't want you to say it diverges by the alternating series test, which is what the box here says. It diverges by the nth term test. That's the one where you take the limit, and if it's 0, then it has a chance, and if it doesn't, if it's not equal to 0, then it has no chance of converging. That's what you want to say. So this diverges by nth term test. Nice. So notice I only checked the limit requirement. If this had been 0, then I'd have to check the other two that they were met. But if one of the requirements for convergence is broken, then the whole thing, you can't use that test anymore. So this one, watch this. If I check the limit first, limit is n goes to infinity, 1 over n squared. That one does pretty obviously have a limit of 0. So that condition is met. Now I have to check the other conditions, which are, well, there's two different ways to say it. First of all, is the whole thing alternating? That's one way to say it. Or the other way to say it is the part without the -1, is that always positive? Because then the -1 will make it alternate. So let me say it. Let me say it the more formal way. I'll say that the 1 over n squared is always positive. Boom. Yeah, for sure that's true. You plug in numbers. Actually, you plug in any number, even if you could plug in negative numbers. The squaring it would make it positive. Hey, Grace. Are you here to do a test or something?
Yeah,
9. Wait, 8.1 quiz. Oh, yeah, I remember.
Let's go. This part, it's like a -4. So it's like if you plug in like 1, you just get -1. But then if you plug in 2, you get 1. So it just gets changes from negative
Great luck.
to negative positive. And basically, most of the time it's going to convert. And that's what's doing that, I guess. But we haven't really, kids don't have to do that.
All right, check two things. Is the limit 0? Is that thing positive? And then lastly, does this decrease? And again, the way to check that is if I plug in 1, then 2, then 3, then 4. As I keep plugging in bigger and bigger numbers, does this overall fraction get smaller and smaller? And the answer should be yeah, of course, because the denominator keeps getting bigger and bigger. So does this decrease? Yes. And now all three conditions have been met, so now I can say this for sure converges by the alternating series. Question?
2 questions. Like, so you're testing like the part that's not the -1 to the n, right?
Yeah.
You don't need to worry about that like at all when you're doing any of these tests.
No.
And then do you also like if like on the AP test they ask this, do you have to like write out limit yada 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 equals 0, this is positive and this decreases, or if you just like okay, this converges because of like how would you
say? Okay, it depends because I've seen it a couple ways. If it's on a free response question and the point of the question is does this converge or not, then you might just want to give a quick sentence like since the limit is 0 with this being positive and that being decreasing, it converges by the alternating series test. Sometimes they won't check that. But like if it's on a multiple choice problem, then they'll just ask you which one of these converges and you'll just have to check on your break. So sometimes you do have to write it, sometimes you don't. Yeah, we'll look. We'll have like 2.5 weeks to review, so we'll review that when we get there. But anyway, the sum converges by alternating series. Boom.
The sum converges or the series?
Okay, yeah, maybe you could say series. I mean, they're interchangeable. All right. Questions on the test itself. Again, the main thing that needs to happen is that the limit needs to be 0 of the non-alternating part, the non-negative one part. Yeah.
And then if the limit isn't 0, that automatically proves divergence? Or...
Yes.
Okay.
Yeah, so this one is pretty straightforward.
Because it's already proved by the end.
Exactly. Yeah, that's a thing that we learned.
All right.
10-1. Nice. Yeah, you guys, good job. All right. Next page is kind of cool because it gives you an idea visually of what's going on with alternating series and why they have a better chance of converging. Is because, well, if they're going to converge, then those three things need to happen. It needs to alternate in sign, it needs to be decreasing, and the limit of the terms needs to be 0. So if you think about that visually, if you take the partial sums and you add each individual term, you start at 0, then you add the first term, and you get as big as you can get. Because now you're going to subtract off something smaller than the first term from it. But you're going to get smaller, but not way smaller. You're going to get smaller by a little bit. And then you're going to add something that's not as big as that second term. So you're going to get whoop to here, and then you'll add the fourth term, and that's not as big. Or sorry, you'll subtract the fourth term, that's not as big, so that'll go here. Then the fifth term, then the sixth, etc. So the sum will be what you're like jumping around each term. Yeah? Okay, that'll become a big deal in a second, but as long as we're all on the same page, keep that in your brain. And then it kind of breaks away from this idea for a second, talking about absolute and conditional convergence, which used to confuse me as a student, but it's a very simple idea. You guys just told me that alternating series have a better chance of converging. And so this idea of absolute versus conditional convergence just checks, did the series only converge because it was alternating, adding, subtracting, or would it have converged even if you weren't subtracting? If you were just adding all those terms, would it have also converged? So if it would have converged even if it wasn't alternating, that's called absolutely convergent. And then conditionally convergent is if it only converges because it's alternating. But that's not what it says in this box. In this box, it says it more formally, which says that the absolute value either converges if it's absolutely convergent, or if the absolute value diverges, then that's called conditionally convergent. So basically, this just means without the alternating bit. That's basically what that absolute value means. If you just think about taking the absolute value of, like, here's one written out. When it's all condensed into sigma notation, it can be confusing, but hopefully I've convinced you. Look at, if you take the absolute value of each of these terms, then you're just going to get 1 plus 1/2 plus 1/3 plus 1/4. So that's why I'm saying the absolute value, all it does is check if it wasn't alternating, what would the series be doing? Okay. Then it has an example about does this converge absolutely or conditionally? So let's check that. First of all, let's check whether it even converges, because if it diverges from the start, then that's less work for us. That we can just say diverges and then we're done. But if it converges, then we have to check absolutely or conditionally. So 3 requirements. Here's me not saying. See if you can check the 3 requirements yourself. You can just check them real informally, like put check marks like we did in the last one. Nothing new yet about absolute or conditional. We'll do that together. But just check the alternating series then. Those were the three conditions. Or you instead of saying if this is positive every time, you could have said does the whole series as a whole alternate in sign. But the answer is equivalent. Both ways you say yes. So all three conditions were met. Nice. Now you can say therefore this sum converges as written. But now if we're going to check, if we're going to say is it absolutely or conditionally convergent, now we have to check would it have converged if it wasn't alternating. So in other words, we have to check we have to check this series n equals 1 to infinity. I didn't know how to write it. But basically the absolute value of this series, we have to check if that converges or diverges. That's what it says up here. Boop, boop, boop. That's what I'm checking. Okay, and when you write it like that, it's like a sigma. There's a -1 to the n. There's an absolute value. There's a square root. It looks very confusing. But again, just think about it. If you wrote it out, this would just say 1 over square root of 1 minus 1 over square root of 2 plus 1 over square root of 3, etc. It just alternates signs. So if you take the absolute value of each of those terms, all this does is it just makes every term positive. So in other words, each time you check this, every time, all this is going to do is get rid of the -1 part. Well, unless there's some crazy thing they're doing with like sines and cosines that are alternating from -1 to 1, but you wouldn't see that. Like for 99% of the problems, this is all that's going to happen. Cool. Okay, so now I'm just checking whether this converges or diverges. So here's me not saying anything again. You technically know if this converges or diverges just by looking at it, but I mean, you guys are new to this, so you may have to flip back in your notebook a little bit, but see if you know if that converges or diverges. Here's 40 seconds. Okay, was that 40? What'd you say, converges or diverges? Hey, nice. Yeah, you should have said diverges, actually. Even though it does get smaller and smaller and smaller, this diverges because it's a p-series with p being 1/2. In fact, if it helps you, you can write it like this. That's a p-series with p being 1/2, so therefore this diverges. Actually, let me not even write the little implies there. I can just say that series diverges. Because p is less than 1. Nice. And so therefore, you can say the alternating version converged, but the like the non-alternating version diverged. So therefore, that's called conditionally convergent. It only converged because it was alternating. You can say, so this converges conditionally, or I'm just going to use the language that they said in the problem. This is conditionally convergent. Nice. All right, so don't forget that there's only one example because it's like it's not super tough to do, but it is important. Don't let the one example make you think that it's not important. So don't forget this. I think in your homework you have to check a couple times, so you'll get some practice there, and you do see it from time to time on the AP. All right. conditional or absolute convergence. Then the next term is kind of fun, I think. It's called the alternating series error bound, which you'll know a lot of different error bounds. We actually did a little bit of this with the integral test. But what this says is if you only use a certain number of terms to approximate your sum instead of going all the way out to infinity, then how far off could that sum be? And if I go back, like what this basically says is better illustrated in this picture. So you know how we said like each jump, each time you add a term, you're jumping by less and less. So what that means is basically, let me get rid of all these markings. Let's say I used 4 terms to approximate this sum, then I would say, oh, this is the value of the sum if I just use 4 terms. And so the farthest I can be is like my fifth term is going to overshoot the actual value of the sum. So the farthest off I can ever be is just the next term. Like what I mean is this distance from here to the 5th term, which they didn't show, but I'm like approximating it might be around there. That would be the distance to my like the distance from here to the 5th sum. That's just the next term. That's going to be way more than the actual distance from there, from my approximation to the real value of the sum. So what this says is that if you use a certain number of terms, n terms, to approximate this infinite sum, the farthest you can be off, the error for that, will be at most the next term in the sum. So again, if that's not making sense in general, here's a specific example, and then you'll understand what I mean. So first it says, here's the sum, approximate that using the first 4 terms. Oh, and we'll get to talk about this n factorial, which if you don't know about factorials, you'll get very familiar with them by the end of the unit. But okay, here is us approximating this sum with just 4 terms. In other words, just going from n equals 1 to 4. Okay, or sometimes I just call this s sub 4. That might have been easier to write, but I've already committed to this. Okay, what this n factorial means, do you guys know? Can you explain it? No? Yeah. Yeah, it's all the numbers multiplied together up to that number. So 1 factorial will just be 1 because there's no numbers before it. So if I plug in 1 into this, it says n equals 1, by the way. If I plug in 1 into this, I get -1 to the 2nd power. So positive 1 over 1 factorial is just 1. But I'll show all my work. Then I know this is going to alternate, but just to convince you, if I plug in 2, that'd be -2 to the 3rd power, or sorry, -1 to the 3rd power is -1, so -1 over, and then 2 factorial is 2 times 1. But I'll write this for now. And then plus 1 over 3 factorial minus 1 over 4 factorial, and that's as far as I want to get. All right, but again, what's this actually look like? 1 factorial is just 1. So 1 over 1 is 1. 2 factorial is 2 times 1. So that's just 2. 3 factorial, this is when it starts to make a difference. 3 factorial is 3 times 2 times 1, which is 6. And then 4 factorial is 4 times 3 times 2 times 1, which is 24. And then we'll actually need to calculate this for like the other parts of the question. So if you put that in your calculator, you get 0.625. Question.
There's always going to be like factors. Like they're all factorable into the same.
Wait, it's actually.
Like number two, right? So isn't it like if you do not have fraction?
Oh, that was cool. Oh, that was cool. Yeah, that's smart. Yeah, that's true. Yeah, same saying, if you didn't have a calculator, this wouldn't be that hard to calculate because they're all factors of each other since you're just adding one more factor to each one. So it wouldn't be that hard to get a common denominator. Nice. All right, that's part A. That's if I use 4 terms instead of an infinite number of terms. But then it says, use the error bound to show that this is only less, well, let me just read you what it says. Use the alternating series error bound to show that this approximation differs from the actual value by less than 0.01. So only using 4 terms instead of an actual infinite number of terms is only this far off from the real, or at most that far off from the real value. And the way you do this is, again, you take advantage of the fact that you're adding and subtracting less and less each time. So the farthest I can be from the actual value of the sum is just the next term. So the last term I stopped at was 4. My error will be the value of the 5th term. Actually, maybe I should say it like this. Maybe I should say error will be at most the 5th term, and the 5th term is just 1 over 5 factorial. And 5 factorial, again, would be 5 times 4 times 3 times 2. So 5 times 24, which is 120. If you start dealing with factorials enough, you start learning them. So that's not me doing that math real quick. I just had that memorized. So 1 over 120. And then they asked me to show that the error would be less than 0.01, which is 100th. And now I've done it because 1 1/20th is less than 1 100th. In other words, what I just showed, 1 1/20th is 0.0083, which is of course less than 0.01, like they asked me to show here, less than that. So I've done it. That's it. Cool. So kind of interesting. If you only use 4 terms, you're that far off from the sum. At most, you're that far off. So you can imagine using 10 terms is going to be very, very, very close to the actual value. All right, and then part C says use that result to explain why S can't be 0.7. And this one I think you guys can figure out. Why can't the actual value of the sum be 0.7? I thought you would answer right away.
We just proved that the original answer of the 4th value, 0.625, is within 100th of the correct answer.
Yeah, that's it. Here's what we approximated. Here's how far off it could be. And so the even if I add these two together, even if it was the farthest it could be off, this is still not going to reach 0.7. Formally, the proof would look something like the actual value of the sum. Let me do it like this. Or let me use the S that they said. Sorry. I'll just use the S that they talked about here. So I'm going to say the actual value of the sum is at most my approximation plus my error, which is 0.635, which is not 0.7. Or in other words, just to make it super explicit, that's strictly less than 0.7. So in other words, my sum has to be less than 0.7, not equal to 0.7. And that would be a good enough proof for anybody. Question?
It's not even the 0.01, it's a point.
That's true. Yeah, that's way true. That's that this is to make it even more accurate, you could say 0.625 plus this actual error could go there, and make it even more clear that it's less than 0.7. But yeah, maybe I should do that. 0.083 which gives you 6333. And then it's even smaller than what I had said. Nice. Okay, alternating series airbound makes sense conceptually and procedurally. Any questions? Okay, then you have one more, but it's kind of interesting. It's kind of fun. I don't even want to say anything about this one. It just says how many turns are needed so that your error is less than that much. So let me let you guys try that, and then we'll go over the answer in a little bit. Here's 3 minutes. It might need more. But maybe. You have those blue calculators if you need to. Where you
I was about to say 100, but that's not true.
Well, this doesn't really depend on this. Yeah. You need this the
It's the
first.
fourth rule, right? Yeah, which that's
So base, but
That's not. It's the rule.
well, I'm here to help you get a specific question. Nice. Oh, right. You did it that way.
Sure. Is there like a negative absolute value?
Like that makes everything negative?
Yeah.
Not its own symbol, but I guess you could just take the absolute value and put a negative in front.
Yeah.
That's
I have another-
interesting.
I have another question. How does titration work? I like watched a video on it.
I don't know
At
that
night. It's like the one. It's like instead of like 6 to the 3rd, it's like that.
Whoa. I don't know. What did the video say?
It said it created some like gigantic amount, but I don't remember how like
That's
what it
great.
actually does.
I don't even know that notation. I've never seen that notation. That's not bad. That's a good start.
And
They're okay. They're pretty good. Actually,
I've been halfway, bro. I just hate the episodes when they're with anyone else. I always skip them. I'm like, crap.
No, sometimes it's
this question.
well, it's like
Sometimes when Billy goes on, it's like,
But it's like small mistakes like that.
some of them are so just like shit. Where
Yeah.
it'll just be like
Yeah,
it'll
you
just
can
be some
watch
fucking like limited thing.
chug, bro. And it'll just ruin their flow.
No, but sometimes yes, but
Okay.
like I was listening to this one.
You should have said. Well, actually, I saw a good amount of people get the answers. Guy, what did you say?
I said it takes 5 turns.
Because why?
The 6 values are less than 1,000.
That's the way I did it. Is I just checked. You know how the error will just be the next term in the sum. So I just checked what's the first term, what's the second term, third term, etc. until I got one that was bigger than 1/1000 or smaller than 1/1000. So what I mean is A1 is 1/1. A2 is, or the absolute value. I'm just gonna not worry about the positive or negative. That's why I'm putting absolute value. Or the second term is 2 to the 4th is 16, not bigger than 1000 yet. So the third term is 81. Is it not? Yeah. The fourth term is 256, still not smaller than 1/1000. Fifth term is 625, still not smaller than 1/1000. And then the sixth term is 1296. Boom, so there's the first one that's smaller than 1/1000. Meaning if I use 5 terms, 1, 2, 3, 4, 5, then the sixth one, this error right here, would be smaller than 1/1000. That's the way I did. So let me finish my answer. If we use 5 terms, the error will be at most a sub 6, which is equal to 1296, which is less than 1/1000. Nice. I think that's the easier way to do it, but then I also saw Sam's way and James's way, which was they set up an equation, which was cool. They said, okay, when is that less than this? Like, what does n need to be so that this is less than that? In other words, when does 1000, when is that less than n to the 4th? And then they took the 4th root and they got 5 point something. What you get? 5.623. Meaning that if you use 5 terms, then that is not bigger than 1000. But the 6th term will be bigger than 1000. So you need to use 5 terms total. That's your approximation. So same answer. Cool. But either way you do it, you should get 5 terms. Nice, and I think that's it. Next is 10.5. Sweet. Good job, y'all. All right, like I said, yes, class tomorrow. No class Friday because I'm out in the morning. And we're getting there, you guys. Then when we come back from break, we only have a few sections.